Okay, go.
Oh, go?
Yeah.
I cut this down. All right, so these constrain the solution to here. They actually constrain x value and y value. So how do we determine what our maximum value is? Well, I'm going to take all the feasible points and put them on a graph. So let me write my feasible corner points here. Okay, my feasible points. I have 0, 0. I have 7 and 0. I have the intersection point 6 and 2. And I have 0 and 5. So now we got that from the graph. Right now we don't need the graph anymore. So we'll get rid of the graph. And the next step is to develop a comparison table. So I believe step 4, you want to make a comparison table. What we're going to do is we're going to have on this side feasible corner points. And we're going to have our objective function. Our objective function, our objective is to maximize profit. And it's given by 30x plus 40y. All right, so let's look at our points. Of course, 0, 0 is a and 7 and 0. And 6 and 2. And 0 and 5. Now let's substitute here. Of course, this is a ridiculous solution. 30 times 0 plus 40 times 0 equals 0. So that makes no sense, but it is in the feasible region. Now here it says x is 7, y is 0. So P equals 30 times 7 plus 40 times 0. That's 210. Let's say that's dollars. Now this one, let's do the bottom one first. X is 0, y is 5. 30 times 0 plus 40 times 5. And that equals 200. Now the next one, x is 6. And y is 2. So we're going to get here 180 plus 80. That's 260. So what's my solution here? My solution is produce x equals 6 units of product A, y equals 2 units, and your profit is going to be $260. That's the largest value that we got from here. So I maximize profit when I produce 6 units of product A and 2 units of product B. Now that was a created example. I'll have you write this down. Then I'm going to do a real example where we have a manufacturing process. And on your notes, you'll find this example on page 4. Page 4 of your notes. Okay, it's called the River Company. All right, so basically what I did is I found my feasible points by graphing my constraint equations as equalities, finding the x and y intercepts of both equations, then finding the intersection point of both equations. Got my feasible points, the points that were closest to 0, plus the intersection point. I substituted them in my objective function, created a comparison table, found out that if I produce 6 units of A and 2 units of B, product B, I make a maximum profit of $260. Okay, now let's do a real problem. Well, semi-real anyway. Okay. So if you look at page 4 of your notes, right, so this is example. It's the River Company. And it's a microbrewery. It produces a lager and an ale. So microbrewery produces 2 products, a lager beer and an ale. All right, now each product depends on the availability of corn and hops. So they give you a availability chart. This is the ingredient. It's going to be corn and hops. Okay. And in the lager, it says you need 3 pounds. Can't get these right. 3 pounds of corn per barrel of lager. So we're making this in barrels. Hops, you need 2 pounds of hops per barrel of lager. Assuming those are the only 2 ingredients, so usually aren't. Now for the ale, we know that we need 2 pounds per barrel of corn and 2 pounds per barrel of hops. Now what's available here? These are where our constraints come in. So let's say it's going to be per month. Available per month. Well, they say there's 1,200 pounds of corn that they can get in and 1,000 pounds of hops. All right, so step 1, here we're not given the constraint. I'll say their profit. So the objective function is not given either. What is given? It's given that profits are $35 per barrel of lager and $30 per barrel of ale. So that means we're going to let X equal the number of barrels. And what did I do here? The number of barrels of ale produced. And Y equal the number of barrels of lager produced. So step 1, create the objective function. I want to maximize profit. Well, it's $30 per barrel of ale, and there's X barrels of ale, so it's going to be 30X. There's Y barrels of lager and $30 per barrel of ale profit. $35 a barrel of lager profit. 35Y. I now have my objective function in mathematical form. The next thing I have to do is to develop my constraint equations. Okay, I'll have you write this down here, that these are on in your notes. I want to keep this on here for now. So the objective function is, we could put that in here so we have it. So the objective function is P equals 30X plus 35Y. Okay, so let's erase this. And step 2 is to develop your constraint equations. And the other problem they were giving us. And the problem you're going to get in a final, they won't be. Develop constraint equations. Now, we will only be dealing with less than or equal to constraint equations. So this is maximum available. So this would be less than or equal to, less than or equal to. So let's look at the first constraint. So the corn constraint. That would be equation 1. Well, 3 barrels per lager. So this is, ale is X and lager is Y, right? That's how I defined it. So I got 2 barrels of X, 2 pounds per barrel times the number of barrels, 3 pounds of corn per barrel of lager plus times the number of, so 3Y. That's going to be less than or equal to 1,200 pounds. This is pounds per barrel times barrel is pounds. Pounds per barrel times number of barrels is pounds. Okay, so 2X plus 3Y. Now the hops constraint.
We're at 13 minutes, just FYI.
Okay. I got 2 pounds per barrel of ale and 2 pounds per barrel of lager. So that's an easy one. 2X plus 2Y is less than or equal to 1,000. So we just stop at that, and this will probably go 45 minutes then.
Okay, so we'll
right.
stop it here.
Yeah, all right. We'll stop it here, and we'll come back.